They said you needed massive data and billion-dollar supercomputers to build a state-of-the-art AI. They said open source models couldn't compete with closed systems trained on mountains of proprietary data. But guess what? A new AI, OpenThinker 32B, just crushed DeepSeek R1, and it did it with just 14% of the training data. This shouldn't even be possible. For years, the biggest names in AI, think openai, DeepMind and Anthropic, have dominated the space with models trained on hundreds of billions of tokens, using thousands of high-end GPUs. These companies operate behind locked doors, keeping their datasets, training methods, and model architectures a secret. They rely on brute force training, feeding their AIs absurd amounts of data and compute. But what if there was a smarter way? Today we're looking at two AI breakthroughs that are changing everything. First, OpenThinker 32B, an open source model that's outperforming some of the biggest proprietary AIs while using a fraction of the resources. And second, Hugin 3.5B, an AI that thinks in hidden loops, refining its own reasoning without wasting computational power. If you care about the future of AI, open source innovation, or just mind-blowing breakthroughs in reasoning, you're in the right place. The rise of OpenThinker 32B. Let's start with OpenThinker 32B, the model that's making waves across the AI community. Developed by the Open Thoughts team, this model is based on Alibaba's Qwen-2.53T-Tolb Instruct and boasts 32.8 billion parameters with a 16,000 token context window. But the real magic? It was trained on just 114,000 carefully curated examples, while its closest competitor, DeepSeek R1, used a staggering 800,000 training samples. So, how did OpenThinker 32B manage to outperform larger models with less data? The answer lies in precision training. Instead of just dumping random internet data into the model, the team at OpenThoughts used a specialized dataset, OpenThoughts 114K. This dataset wasn't just large, it was highly structured, including ground truth solutions to complex problems, domain-specific guidance for coding and reasoning, test cases for code verification, AI-based judges to confirm math proofs. Essentially, instead of relying on sheer volume, they ensured that every training example counted. And that approach worked. On the Math 500 benchmark, OpenThinker 32B scored an impressive 90.6%, beating DeepSeek R1, which landed at 89.4%. It also scored 61.6% on the GPQA Diamond benchmark, a test that evaluates general problem-solving ability. Again, this was significantly higher than DeepSeek R1's 57.6%. But where OpenThinker 32B really shines is in its efficiency. Training massive AI models typically takes weeks or even months of continuous computation. But OpenThinker 32B was trained in just 90 hours using AWS SageMaker, running on 4 nodes with 8 H100 GPUs each. And for even more experimentation, an unverified version of the model was trained on Italy's Leonardo supercomputer, using 11,520 A100 GPU hours, finishing in just 30 hours. So, what does this mean? It means that open source models are now capable of competing with the biggest proprietary AIs, and they're doing it with less data, less compute, and more intelligent design. And if OpenThinker 32B can do this today, imagine what future versions could accomplish. Hugin 3,5 biljoner. As impressive as OpenThinker 32B is, Hugin 3.5B is breaking AI in a totally different way. Instead of just improving data efficiency, Hugin introduces a brand new approach to reasoning itself. Developed by a team of researchers from the Ellis Institute, Tübingen AI Center, Max Planck Institute for Intelligent Systems, University of Maryland, and Lawrence Livermore National Laboratory, Hugin 3.5B isn't your typical transformer model. It uses something called latent reasoning, a method where most of the reasoning happens inside the AI's hidden layers, rather than being explicitly written out in token form. To put it simply, most AI models solve problems like a person talking through their reasoning out loud. Hugin 3.5B, on the other hand, thinks quietly, refining its internal state before giving an answer. This is made possible through its recurrent depth mechanism, a feature that allows the AI to loop over its own internal state multiple times during inference. Think about it like this. If you're solving a difficult math problem, you might go back over your work, double-checking and refining each step before arriving at your final answer. That's exactly what Hugin 3.5b does, but inside its hidden layers, without wasting extra tokens. This approach has two major advantages: better reasoning for complex problems. Tasks that require multi-step logical thinking, like math proofs or code generation, benefit massively from this iterative refinement process. Huge gains in efficiency. Traditional chain-of-thought reasoning models require longer outputs, which consume more tokens and more computational power. Hugin 3.5b, however, refines its answer internally, making it far more memory efficient. Even though Hugin 3.5b is a relatively small model at 3.5 billion parameters, it punches way above its weight. In benchmark tests, it outperformed much larger models like Pythia 6.9 billion and Pythia 12 billion on reasoning-heavy datasets including ARC and GSM 8K. One of the most fascinating features of Hugin 3.5b is its adaptive reasoning depth. The model can increase the number of internal iterations for difficult problems, allowing it to take extra time to refine complex answers. But for simple queries, it can shortcut the process, answering faster while using less computational power. This means Hugin 3.5b isn't just smart, it's also highly adaptable. If you're running AI workloads on a budget, this feature could be game-changing. Instead of always needing massive compute resources, you can adjust the depth of inference dynamically, saving power while still getting high-quality answers. What this means for the future of AI. Both OpenThinker 32b and Hugin 3.5b are proof that AI innovation isn't just about who has the biggest dataset or the most GPUs. Smarter training methods, latent reasoning, and efficient architecture design are quickly leveling the playing field. For open source AI, this is a massive victory. The success of OpenThinker 32b proves that you don't need to be OpenAI or Google to build world-class models. And Hugin 3.5b shows that better reasoning isn't just about scale, it's about designing AI to think more like humans do. So where does this leave big proprietary models? Well, they still have a head start in scale, but models like OpenThinker 32b and Hugin 3.5b prove that the gap is closing fast. If open source AI keeps evolving at this rate, we could see a future where anyone, not just trillion-dollar tech companies, can build and deploy cutting-edge AI. The AI world is changing faster than ever, and models like OpenThinker 32b and Hugin 3.5b are redefining what's possible. What do you think? Let me know your thoughts in the comments, and if you found this breakdown interesting, don't forget to like, subscribe, and share. It really helps support the channel and keeps these deep dive AI discussions going.